Hi, everybody. Welcome to Greening the Grid webinar today. We are just waiting for a few people to join. We know how many should be joining, but we're just going to wait one more minute while everybody joins in. Okay, so it's 2:01 and going to, no, that's not what I'm going to do. Okay, I'm going to welcome everybody today to Greening the Grid. I'm going to introduce our panelists today. We have Ed Rubenstein. He is the Vice President of Noventa Energy Partners. With nearly 25 years experience leading internationally recognized environmental sustainable programs, Ed is a proven leader in the field. Ed is a member of the esteemed 2018 Clean 16. Ed's expertise spans key areas, including district energy systems, climate change, resilience, energy efficiency, waste management, and risk management. He is passionate about fostering behavior change and developing innovative policies that drive performance and engagement. And we have Leslie Smith. She's a business development manager for Blade Air. Leslie's a seasoned expert in air filtration with over 10 years of dedicated experience in the field. She's passionate about sustainability. Leslie has consistently focused on developing innovative air quality solutions that not only enhance environmental health, but also promote energy efficiency. And then we have Jay Chan, who is an MBA Senior Supplier Relationship Manager with OECM, which is Ontario Education Collaborative Marketplace. He's a manager with extensive expertise in project management and procurement. Jay excels in research, analysis, and problem solving, bringing a keen understanding of the broader public sector procurement directive and CETA and CFTA trade agreements to his work. Jay is dedicated to fostering positive relationships and achieving organizational goals. We're excited to hear his insights today. And then there's James, and last but not least, James Atkinson is a mechanical engineer in training, EIT, working towards the professional engineering designation in Ontario. With a background in medical equipment and HVAC, he's learned the importance of creating eco-friendly alternatives and green energy in today's industry. Okay, so I'm going to hand it off to Ed now.
Thank you, Kelly, and welcome everyone. So again, my name is Ed Rubenstein. I'm a vice president with a company called Noventa Energy. We are a company, a renewable energy company that provides thermal energy through wastewater. I will share my screen now, my presentation. I have a few slides over here. I'm going to talk a little bit about this whole wastewater energy capture. I'm going to focus on what's a really exciting project. And part of my previous life was a installation that's almost near completion at Toronto Western Hospital. Okay, let me just get set up here. Okay, so again, Noventa Energy, we're a renewable energy company delivering projects through an energy as a service model, which I'll get into some of the benefits of that along the way. And we have access to this technology from a company called Huber. They're a German wastewater handling manufacturer. And because of this, we now have the ability to extract and reject thermal energy from wastewater. So let's talk a little bit about that. So you may think sewage, why would we even want to use that? Well, sanitary waste is actually an undertapped resource. There's a lot of this flowing all across North America and the world. And the thing about sanitary water is that it's predictable. So the temperatures will go up and down a little bit, the flows will go up and down, but by and large, it's a consistent temperature and it has predictable flow profiles. So I like to say it's sort of like a geothermal field that with a geothermal field, you need to worry about balancing your heating and cooling loads. When it comes to wastewater, as long as that wastewater is flowing, and there's a lot of it, and it's always flowing, it's constantly renewing. So there's some advantages in looking at wastewater energy recovery as compared to geo. So this is sort of like a schematic of how it works in terms of cooling, right? So remember, we can use the wastewater as a thermal heat source or a thermal heat sink. So on the left-hand side, you've got a conventional cooling system with a chiller, right? You could see kind of that wavy thing at top. That's a cooling tower. So you're rejecting heat to the environment via a cooling tower. Water is evaporating. That's good. I mean, that works really well. We have many, many buildings that have this. However, what tends to happen is that when you really need your cooling system the most, so on those hot, humid days, when you're trying to reject the heat to the environment, because it's hot and humid outside, the efficiency or the coefficient of performance of your cooling system is greatly diminished because of the outdoor conditions. Because wastewater is not as impacted by outdoor conditions as the outside environment is, you can see on the right-hand side, by rejecting heat to wastewater, you're usually going to get a higher coefficient performance. And we like to say, depending on the situation and the temperature of the water and stuff like that, we can usually guarantee a coefficient performance on the cooling side of about 6.5 compared to maybe 5 or 6 under best conditions for conventional systems. Also, you can see on the system on the right, so this is a wastewater energy system rejecting heat to the sewer, and you can see that cooling tower is crossed out. So potential for huge water savings because all that water is rejecting heat through evaporation. If we're just dumping that heat to the sewer, we no longer need that water. So that's an advantage there. If you're looking at greenhouse gas emissions, there are going to be energy savings. So primarily around scope 2 emissions related to electricity use, maybe reduced water consumption, you're going to see a benefit compared to conventional systems. But where the wastewater energy system and Noventa's wastewater systems really shine for decarbonization is compared to conventional heating systems. So on the left-hand side, you can see this is looks like a gas boiler we have there. You're lucky if you get an efficiency maybe of 80% or a coefficient performance of 0.8. If you move to electric boilers, you might get an efficiency of 94 and 95%. Using a heat pump and extracting thermal energy from wastewater, so the picture on the right-hand side, it's the magic of that vapor compression cycle, the magic of heat pumps. We can usually guarantee a coefficient performance of about 4.5 or higher. So about 4 to 5 times more efficient than even an electric boiler, right? So this is huge in terms of decarbonization. People are probably very familiar with the idea of heat pumps. I'm having one installed in my house right now. It's an air source heat pump. It's taking heat from the outside air, but there's so much thermal energy in wastewater that the heat pumps, when extracting heat from that, are much, much more efficient, which really enables a lot of opportunity in terms of decarbonization. Okay, so that's the kind of the principle. So this is what we call our wastewater energy transfer system. I think you guys can see my mouse, but everything is labeled here. So A on the left-hand side, this is a municipal sewer. So just to clarify, this is not wastewater coming out of the building, but we are tapping into larger municipal sewers, right? So we have the I guess the input from the entire municipality or whatever houses are connected to that. And then what we do, B, is we put down a vertical shaft. We call that a wet well. And then through gravity, we're allowing that wastewater, that raw sewage, to flow into the wet well. And the first piece of Huber equipment, C, it's called the ROK4 or Rock4 wastewater screen. This is made by Huber. This is designed for separating solids out of wastewater. This is part of their standard offerings for wastewater handling, right? We found that it's a very good application for extracting thermal energy. So a couple things here. First of all, you can see by having a wet well here, we're not actually impeding what's going on in the sewer, right? So we're actually just going to be boring a bit of thermal energy from that sewer, and then that wastewater is going to go back. And then by having this mechanical separation, it really avoids some problems you can have with other ways of handling solids and wastewater. Again, this piece of equipment is designed to pull out solids. And I should point out, it's also self-cleaning. So what happens is the wastewater flows through this pipe. There's a basket with quarter-inch perforations there. All the solids that get caught on the inside are going to be augered out. There's a wire brush auger on the inside. It's going to pull them up, and those solids go right back in the sewer to end up at the wastewater treatment. All right, so we've got the wastewater coming in. It's been screened. We then use wastewater pumps. That goes up to the next piece of Huber equipment, E. This is a heat exchanger. I've got some really good animation coming up in this. The beauty about this is it's a self-cleaning heat exchanger, because even though we screen out solids, this is obviously sewage. There's obviously going to be a high level of bioburden in here, which means you're going to get biofilms building up. Biofilms would reduce the capability for heat transfer. By having the self-cleaning system in here, you'll see when we have it in a couple slides, we can maintain consistent heat transfer. And this is key. This means that that energy, the thermal energy we have in the wastewater, can consistently be harnessed to be put to work. We've done that in E, the heat exchanger, and then it goes to F, heat pump, right? So the heat pumps, it depends on what the building needs or what the system needs. You know, you have heat pumps these days that can make steam. Heat pumps can make high temperature hot water, low temperature hot water. You really, you know, that part of the system is designed so that it meets whatever the building's needs are or whatever the system's needs are. And I guess just one last thing to point out here, you can see G. This is our energy transfer station where we have our heat exchangers and heat pumps. A lot of flexibility here. This picture has it sort of like a standalone building, which means, you know, this can be standalone, saving space in mechanical rooms. This equipment can go in mechanical rooms. It can go be buried underground. It can be on property, off property. You don't even need the heat pumps and heat exchangers next to each other, which means there's a lot of flexibility as to where you put this. So we can really, when we're designing these systems, we can take a look at the space, the footprint available, and then come up with a solution that best fits from a technology perspective and also a cost perspective. All right, so that's a schematic. Here's a heat exchanger. Again, this is pretty incredible, and it's very simple, yet very robust and very effective. And all it is a series of O-rings that fit perfectly over the two bundles, and then there's a trolley system. And what happens is, based on either a scheduled event, so every 6 or 8 hours, or by monitoring the performance of your heat exchanger, that trolley system is going to pull those O-rings across the two bundles and literally wipe them clean, right? So it's mechanical cleaning. So I like to say it's sort of like if a bird poops on your windshield, if you wipe it off right away, no problem. You're going to have a nice clean windshield. If you let it sit, it's going to harden. It's going to cause you all kinds of problems. And you can see here this kind of cutout on the right-hand side. These are mechanical supports, so they have not been wiped clean. Not surprisingly, you've got a lot of biofilm building up there. Whereas on the left-hand side, the O-rings have gone through, nice and shiny. You're going to get that consistent heat transfer. So I got a little bit of an animation here to show how it works, right? So on the outside, you're going to have your screened wastewater. On the inside, you're going to have clean water or glycol that's eventually going to go to your heat pumps. You're going to see the smaller solids that pass through are going to fall through to the bottom. And then as those O-rings are pulled through, everything that's wiped off the two bundles is going to fall to the bottom. And then you'll see there's another screw auger there that's going to take all those smaller solids and push them in the pipe, which are also going to end up back in the sewer. So what happens is that on the right-hand side, you have your wastewater coming in, passes through, you get that heat exchange going on. There's an overflow on the left. And as that water goes in the overflow, it's going to pick up those solids, pick up the solids cleaned up screw auger. All of those solids go right back in the wastewater. So we're not changing any of the physical characteristics in terms of solids. We're not removing them. We're not macerating them or anything like that. We're really just either borrowing a bit of thermal energy or rejecting some thermal energy to the wastewater. Okay, so the system design. Here's the other thing that's really important, and I'll have a bit of a case study, as I mentioned, on Toronto Western, which kind of pulls this all together. So the equipment is available in a whole range of sizes and capacities. So you can mix and match and get what you need, right? These are everything from smaller behind the meter, where you might be taking the effluent from a subdivision or from a building or something like that, to doing large district systems where wastewater is your either all of your energy or maybe like your base load or something like that. Because we have this equipment available in the size of a range of sizes and capacities, it can be installed modularly in parallel, which means it's easy to do things such as N+1 redundancy. So if you need 5 heat exchangers, you put in 6. You've always got one on standby that you can, if you need to take one down for whatever, you've got another one. It also really facilitates future expansion. So when I talk about Toronto Western, there's a phase 1 that's going on right now. There's hopefully a phase 2 that's going to happen shortly. All we need to do to get that energy is drop in more heat exchangers, put in more heat pumps, right? So you could just add as is needed. So as long as you build that wet well at the right size, you can then facilitate future expansion and then purchase, install the equipment as those additional loads come on. Again, this equipment, the screw auger, the heat exchanger, this is designed to handle raw sewage, right? So we don't need to be using clean effluent from a wastewater treatment plant, right? We can go to where the sewer is. And you see for Toronto Western, that happens to be right across the street, 130 feet below grade, right? So that's where the sewer was. That's where we went because we had the equipment that could handle it. Lots of flexibility. And then you'll see also the Toronto Western, what we're doing when we create one of our wastewater energy recovery systems, we're essentially creating a small district system, sometimes a large district system. And you can then start incorporating other sources of thermal energy into that, right? So you'll see at Toronto Western, what we're doing is we're incorporating existing heating and cooling plants, right? Those are assets, they're going to be incorporated. Phase 2 is looking at thermal storage. We have some projects we're working on that's either existing geothermal or new geothermal that's planned. We can add that on as another heat source. So it gives us a lot of flexibility for mixing and matching and ultimately balancing and getting the most capacity from that wastewater as you can by mixing and matching loads and sources. All right. So this is Toronto Western Hospital. So prior to my joining Naventa, I worked at Toronto Western Hospital. So if you see me getting really excited about this, it's because it's pretty close to completion. You can kind of see here, this is an old bank building. It's now owned by the hospital. This is where we put our heat exchangers and heat pumps are. And across the street, it doesn't look like this anymore, but this is the wet well, about 34 feet wide, and it's about 130 feet below grade for accessing one of the larger sewers in the city of Toronto. A little bit about Toronto Western Hospital. I mean, so when I work for the hospital, hospitals are energy intensive. They use a lot of energy. They have a lot of fresh air, which is good during things such as pandemics and stuff like that. They're also a pretty large contributor to Canada's and the world's overall greenhouse gas emissions, right? And a lot of the energy, I'll say, 50% plus is from heating and cooling and HVAC and things like that. So when I was looking for a solution on the hospital side, for decarbonizing and energy efficiency, being landlocked in a pretty busy urban area, really energy intensive, there wasn't a lot that we could look at. We could look at geothermal. There wasn't really the space. Air source heat pumps, you would never get enough energy. Electric boilers would be great. But the draw on the grid, because they're lower efficiency, would be really hard. So one thing we did a lot of work inside the building, and I think Leslie will talk about some of this. Optimizing airflow, reducing energy needs. Once we do that, we're looking at how can we decarbonize. When I had this opportunity to look at this wastewater energy recovery, I jumped on it because it was really the only viable opportunity we had for Toronto Western Hospital. Old hospital, 5 wings, different ages, many modifications over the years. So you heard about these this mythical as-built drawings. We weren't even close to having that at Toronto Western Hospital because it's so old. It had steam boilers and steam distribution system. Like many public sector, there was a maintenance budget like this, and there was, a backlog of work like this, right? So it had deferred maintenance needs. The heating and cooling plants, were well used, super important. They were getting old. There were some reliability issues, some resiliency concerns. And as I mentioned before, limited decarbonization options. It's landlocked. There's not a lot of space to do stuff. Wastewater, we got lucky in the sense that there was a major sewer line coming here. And I said, this is an opportunity that we have to investigate. And as you can see, it turned out to work quite well for the hospital and for Naventa. Now, this is not a simple project, right? So we're kind of discussing before the session started, lots of partners here, lots of collaboration inside the hospital. My job was, I had so many departments from, infection control, finance, facilities, my energy team, right? That outside, the city of Toronto, they own the sewer. We need to work with them. TTC had a streetcar stop there. We need to work with lots of people as well. Equipment manufacturers, both for the heat pumps and the Huber heat exchangers. This project is being delivered through energy as a service, which means there's no capital requirement from the hospital. We need people to finance that, right? So they have questions. So it's a lot of people brought together. And the only way you can do this is through like design thinking, like systems thinking. You can't just have your blinders on saying we need to do this and this and this. So we have to take a step back. Fortunately, at the hospital, we had done a lot of work understanding the building's needs and the energy profiles and stuff like that. And then we could come from a systems thinking, saying, well, what do we need to make this work, right? We need the sewer, we need the energy transfer station. So all of these things came together. And eventually, at the end of the day, we got a scope. This is the project we're going to do. But with that design thinking, it gave us a bit of flexibility to kind of change things along the way as certain conditions arise. Especially here, existing hospital systems. You never know what you're going to find when you open up walls and things like that. Putting pipes in old buildings can be interesting. So we really had to have a lot of creativity. And again, that's the systems thinking to make this, what was a really straightforward technical solution, work in this specific setting. Now, why do all this effort, right? Well, here's the kind of getting, what was designed. So the system is providing about 10 megs of heating and about 9 megs of cooling, sometimes simultaneously. Hospitals need simultaneous heating and cooling. That's about 90% of the annual space heating and cooling loads for the hospital and an adjacent research tower, which has its own standalone heating and cooling plant. And now that's actually only about 60% of the peak loads. The sewer there is more than large enough to provide all of the heating and cooling needs for the hospital and the research tower. So that 60% of peak was really a financial decision. And that's because, as I mentioned, it had a steam distribution system. So one thing we had to incorporate in the project that Noventa took on as an energy as a service offering was converting from a steam system to a hot water system. That's something I always wanted to do while I was at the hospital. But doing that on its own without some sort of payback was a non-starter. I could not ask for all the money that would have been necessary to do this conversion for something later on down the line. What Noventa was able to do is say, hey, we're going to do this for you. The hospital is not going to have to front capital up front, but they're going to do this, the wet well, the heat exchangers, the heat pumps, and the steam to hot water conversion. The hospital is going to pay for that over, extended period through a power purchase agreement by, purchasing hot and cold from Noventa for, the term of the contract. The other thing I want to touch on is it's designed for future expansion. So we had the foresight. So this wet well is larger than what's needed for the current phase, but we knew there was going to be development happening either on the hospital or some of the surrounding property. It's for incremental cost, you make that big vertical shaft bigger. And then, as I mentioned, when that demand comes on, it's easy to drop in more equipment. And this was all done again through energy as a service. There was a small capital contribution by the hospital, but it was not at all required. And it really took away some of that capital risk that the hospital would have otherwise had to do if it was building it on its own and operating on its own. All right, so a lot of work, a lot of collaboration, a lot of things like that. Why? So, my responsibility, my team's responsibility was, greenhouse gas reductions and paying the utility bill. So you can see there over 8,400 tons of carbon dioxide reductions per year, which is 60% of the University Health Network, the larger health network, overall Scope 1 emissions, not just Toronto Western, the overall Scope 1 emissions. Average utility cost savings, just under $700,000 a year. That's great for my budget. Water use, reduced cooling tower. It's about 45 million liters. That's the water that's going to be used per year. A little bit of water savings in the boiler side as well. As I mentioned, the system was designed for future expansion. So, it's there. Now we could add on other hospital buildings or other things if needed. And from the hospital's perspective, that capital risk through energy as a service was transferred, that operational risk. Noventa is responsible for providing heating and cooling under a contract. The hospital no longer has to run its boilers and its cooling plant. Now, $700,000 a year. That's great savings. I love that. It was good for my budget, but the hospital's annual operating budget is around $2.4 billion. That's really a rounding error, if you will. What really helped get this project approved by the board eventually were some of the resiliency redundancy benefits. So in Nuventa, they've taken on that operational risk. We've put in N+1 redundancy. We put up backup generators for our equipment. So if there's a power outage, we can still provide heating and cooling to the hospital. The hospital did not have that capability, right? If there was a power outage, there was, small cooling units for important equipment, but the big chiller system would go down, right? We've now decentralized the heating and cooling system. We have a hybrid system because we're only providing 60% of peak. We still have that 100% capacity available of the existing hospital plant, of the plant for the adjacent research tower. And now, because we put in a new hot water system, we can now backfeed the hospital from the research tower and vice versa. It used to be two very distinct plants. Now they can kind of serve as backup to each other as well. So we've got decentralized system, we've got N+1 redundancy, we have backup generators, and we have the existing plants, which can now, instead of being two separate systems, are now into one thermal network. So lots of resiliency and redundancy. Super important for any business, especially important for hospitals for life and death. We've got renewed hospital infrastructure, so this new hydronic system. So one thing we found during the pandemic is that some of the air handling units have been designed with not enough capacity for 100% fresh air on peak hot days or peak cold days. Well, we're putting in a new system. We're putting in new coils, right? So again, for minor incremental dollars, upsize those coils. So if and when the next pandemic hits, there's now enough thermal energy available for heating or cooling to allow more fresh air to come into the hospital. And then the last thing is there's a I showed you the top of the bank building where all of the event equipment is. That equipment was originally going to go into a vault underground. We did a bit of a pivot because this bank became available, so fantastic. We still have access to that space underground, and thinking right now is to put in a 1 million gallon thermal storage tank, which to probably for simultaneous heating and cooling, which allows us to do peak shaving. So running the heat pumps when electricity is cheaper, when there's less carbon intense electricity. But that's also at the end of the day, 1 million gallons of thermal mass that can then be pumped to the hospital. As long as the hospital is able to take it, we will have thermal energy available for them. Now, that's why the Nuventa is doing it. That's why the hospital is doing it. Why does the City of Toronto want to do it? Well, you know what? We've taken what was essentially a pipe underground full of lots of goodness. And even though it was the good people of Toronto who've created that energy, the City of Toronto has control over it. We will actually pay an energy access agreement through an energy access agreement for the taking of that energy from the City of Toronto, right? So it used to be just sewage flowing to a treatment plant. Now, by us taking some thermal energy or rejecting thermal energy, the city gets a bit of revenue. And on top of that, that wet wells on city property, there's a lease agreement, they're leasing that space to us. So it basically was a road or a sidewalk or something like that. Renewed infrastructure, we had to, the city wants to make sure we're not damaging their sewers or obstructing flow, right? So that means maybe we have to rebuild parts of it or strengthen parts of it so we can ensure that that happens. We have this low carbon district system, so there's a phase 2 happening for the hospital, but the city, like many places in Toronto, they're looking at expansion, right? The city has some pretty lofty net zero goals, so that transform TO goals. Now, if the city builds there is a low carbon district system ready for them to tap into, right? So that's something that is going to benefit them as well. Okay, so I think I'm pretty much on time, and I think we're going to save questions to the end. But thank you, and please hang on to your questions, and then happy to answer after the other panelists have had their chance to share as well. I think it's Leslie is next.
Yeah, I'm next.
Excellent.
Can everyone see my screen? Good.
Yes.
Perfect. Thank you, Ed, for that presentation. That was absolutely, it was very informative and stuff I didn't know. It was great to hear that. And I just want to take a minute to thank everyone who's attended today, taking time out of their busy day. I know that we all have busy schedules, and we do appreciate your attendance. As Kelly said, my name's Leslie Smith, and I am the Business Development Manager at Blade Air. We pride ourselves in not just being an innovative air quality technology company, but we are an air quality solutions company. We offer many solutions, but we're focusing mainly on the intersection of indoor air quality and sustainability. Today, I'm going to introduce one of our newest products. It's called the Blade Air Pro. It is an older system that we've revamped, but it is nothing more than a low pressure MERV 13 filter. We thought, we started Blade Air as an Ontario-based company, and we've expanded our footprint across North America. Very proud to say that. But our goal today is to learn more about what your pain points are and your challenges with filtration and ventilation. Let's work together on solving those. And as we move through the presentation, I please encourage you to write your questions into the Q&A. And at the end of the presentations today, we will answer them to the best of our ability, and also answer, and Ed and Jay will also answer any questions regarding their presentation. So let me just move this. So at Blade Air, why Blade Air? So it's quite simple: energy savings, logistics savings, operational savings, and sustainability initiatives. We have seen case studies starting at 15% by using our Blade Air Pro, and as high as 75% in the distillery district. We have MERV 13 filtration with less than MERV 8 static pressure drop. We reduce your shipment sizes by over 90%, and we have a small storage footprint, maximizing your space utility. We have operational savings, so we reduce your required filter maintenance by half. This enables clients to reduce the size of their new HVAC equipment if they're spec'd in. We also take 100% wasteful process down to net zero, creating a healthier work environment and living spaces. So the Blade Air Pro filter, this is what it looks like. So we exceed MERV 13 filtration with less static pressure than a MERV 8. We have a zero waste, and as I said before, it's a 50% less filter changes. This is also one of the only filters on the market today that is WELL LEED certified. So if anybody does know anything about WELL LEED, it is a no ozone generating product. So this is what it looks like opened up. So we have, again, the simple maintenance, up to 50% fewer filter changes with 92% less boxes. The pad that's encased in here is a breathable filter pad. It is made out of 70% lofted glass material. One of Blade Air's goals by the end of 2025 is to make this 100% sustainable. We have a low power consumption. It requires only 2 watts of power. You can daisy chain up to 6 units in a single power supply on a 24-volt AC connection. And again, scalable solutions. Basically, you just take what's in your solution now, if it's a 20 by 20 by 2, and you pop in one of our Blade Air Pros with no retrofitting costs. Technical specs. So pressure drop, quite substantial. 0.11 on the 1-inch filter to 0.17 inches of water column on the 2-inch filter. VOC reduction. This is something that MERV filters cannot do. So we are very proud to say that we are able to reduce any VOCs, including wildfire or smoke particulate, in a 46% over a 48-hour period. Also, the filtration performance. We are filtering below HEPA at a 0.007 micron range. And as I said before, the energy savings, up to 15%, and with the distillery district, 75% in that case. Very low weight for shipping. Again, the power consumption is 2 watts at a 24-volt, and coming in white or metallic coloring. The housing is actually aluminum plastic. The filter pad is the lofted glass fiber, and we manufacture these in a standard 1-inch and a 2-inch. We also have lead times of 2 weeks. We custom manufacture all filters in Toronto. So you're not looking at 6 to 8 week lead times anymore for filters. And again, the no ozone generated. So these filters have been around a long time. When they were first brought into the market many years ago, they were very energy hungry, and they also emitted ozone. But we have gotten through that, and now we are a non-ozone emitting product. We carry a warranty of 3 years, and again, maintenance 6 months. So I know that the customers that I speak to and my distributor network, one of their main concerns with their maintenance guys is they don't want to be on rooftops in February. And being a national company and deploying this on a national basis, I personally was on a rooftop in February in Winnipeg, and it was not fun. This rooftop had it was a casino, and they had 200 boxes of MERV 9s on those rooftops, and we were able to take those 200 boxes and replace them with 2 boxes of replacement pads, just 2 boxes. And they were astounded, just astounded. And when you compare technology, so one of the big pictures on this Blade Air Pro is when we look at the MERV 13 mandate that the government implemented during COVID, one of the things the government didn't do was take into account the depreciation on your equipment. So what we can do is we can increase that AHU and RTU lifespan by improving the airflow and maximizing your energy savings. Here's a comparison in pressure drops at 300 face velocity per minute compared to a Blade Air Pro 1-inch and a 2-inch against a MERV 8 and a MERV 13. So at the MERV 8, you have 0.32 inches of water column, and the MERV 13 is 0.45. Again, the filtration performance is outstanding, 0.007 microns, again, below the HEPA. The filter life is up to 6 months, and on a MERV 8 and a MERV 13, we're living in a standard world of 3 months with absolutely no energy savings. As you can see, the MERV 8 and the MERV 13 pressure drops is 59% less static pressure on a MERV 8 and 71% on the MERV 13.
Yeah, Leslie, actually, if I could just jump in for a second, just to
Sure.
preempt some questions. If we could go back just one slide to show the open filter casing. I just want to speak to the technology just briefly, because you mentioned the difference between the pleated filter and our Blade Air Pro filter.
Okay.
So if you could just go back, back to the. Oh, it's okay. No worries.
Yeah.
I can speak to it live.
Okay.
Just to specify, this is an electromagnetic filter. So if you see that it's got that metal housing, within that is the fiberglass filter pad that we actually pass a charge over. So you can see there's that power head and the plug at the top of the rendering there. And what that does is create an electric field actually within that metal case. That's why we sort of have that metal case actually forms like a Faraday cage to stop the electromagnetic field from interfering with anything else, any other equipment you may have in the duct. So what that does is actually creates an active force, a polarizing force that's actually going to pull dust into the filter. And that's what gives us that filtration, right? Normal filters work basically like a sieve, where if there's a small enough space between the filter fibers, you will catch dust. Otherwise, it'll go right through. Whereas ours, we actually positively pull dust into the filter fibers. That's why we get dust loading. So we have a much higher level of dust capture before we have it at a high pressure drop, as well as that filtration of extremely fine particles, just because we're actually able to cause what's called agglomeration, where in the presence of a strong field, the particles will actually stick together, become larger, and then become large enough to the point where they actually are able to be captured by the filter. So sorry to cut you off.
No, that's okay, James. I appreciate that. Yeah. So in this slide, so the removal efficiency increases over time due to the particle agglomeration, and the smaller particles stick together, which is what James just referred to. So on this slide, we look at the time trial on the Pro filter against other filters, which are full flow HEPAs, bypass HEPAs, and a MERV 12. And again, the pressure drop against the same filter. So you can see that the Blade Air Pro surpassed on all levels in both time trials on a over a 90-minute period, and the percentage of reduction. So this is one of our most recent case studies. This was done in Toronto, and we're quite proud of this. And actually, I just got news today that this is we had rolled this out into a phase 2 into Alberta and Saskatchewan, and now we're looking at phase 3. So the bank was so happy with the results of the study that we're looking at another 65 locations in Alberta. So we must have done something right. So one of the key challenges that they had was indoor quality energy consumptions associated with installed mandated MERV 13s, the operational efficiency, and they had huge sustainability goals. So the key projects results were energy reduction. So the fan motor consumption was reduced by 31%. They had airflow improvement of improved and increased airflow by 25%, and a staggering 1,800 tons of GHG emissions reduced. These are the actual results, the quantitative results. So in branch 2 or branch 1, you can see the fan motor energy change was actually 14%. And in branch 2, it was at almost 23%. The airflow on the same branches, the changes were 8% on the first branch and 41% on the second branch. And James may be able to talk to that a little bit more if you have any questions on the actual why there was actual changes and the results and the conclusions. He worked quite extensively on analyzing all the data. That was a 6-month trial, and we tore the data apart for that, and hence why the project was so successful. In this slide, we look at the streamlined logistics. So why does it make sense? So as I spoke to before, we're shipping out twice a year instead of 4 times a year. We're able to reduce truckloads. We're able to reduce CO2 emissions. We're creating a smaller footprint. We're maximizing space and utilizing, and there's less on-site storage required. And the one thing I really like about this is the emissions. And I'm going to speak to, in the next slide, the problem. So this is the problem. And when you think of all of the MERV filters and the filters and the bag filters and different types of filters that are in dumps and in dump sites, it's staggering. And one of the things I didn't talk about was with the Blade Air Pro, we can actually look at reducing the number of filters in your RTUs or your AHUs by, if you're running a pre-filter or a bag filter, we can actually replace it with 1 filter. So cutting your filters in half and reducing this problem. So the solution, reducing your carbon footprint. And the solution, and here's the reality, HVAC systems account for 35% of the building's energy consumption, 35%. Making him the single largest energy user in most commercial spaces. This translates to 10% of global energy related emissions, a footprint so large that the governments worldwide set a goal reducing cooling emissions by up to 68% by the year 2050. At this net zero push accelerates, electrification and decarbonization have almost become equal as the industry is innovating, bringing advanced solutions like energy recovery units and heat pumps. But here's the disconnect. While operators invest in new equipment, traditional HVAC filters continue to be an energy drain. They are designed with a flaw that forces operations to choose between energy efficiency and air quality, a compromise that will never allow the full realization of the improvements that these new systems offer. At Blade, we know you don't have to sacrifice energy for better air quality. Our Pro is engineered to solve these very issues. To put this into perspective, if our Pros were adopted worldwide, we could achieve 25 to 30% of the cooling emissions reduction targets today, not in 26 years. This is the power of sustainability. This is the power of clean air, and this is what we can offer the world. Be part of the change. Your journey to sustainability, clean air starts today. The end. So I will stop sharing.
Okay, thank you, Leslie, for a great presentation about the Blade Air Pro. Here we go. Okay, everyone see the screen okay? Perfect. So first of all, I just want to thank everyone again for being in attendance. Thank you to Kelly, Rashab, the association, as well as Blade Air and Noventa, inviting us to share some procurement insights that might be a little bit more beneficial for your group. I'm really here to just give some considerations, takeaways, and how we can navigate some of those discussions and conversations that you might have with your procurement teams, and really how collaboration internally and externally can help you get what you need for your facilities project, asset renewals, maintenance, etc. So here's just a little bit of myself. I'm a senior supplier relationship manager at OECM. My focus is really on all of our facilities and operations agreements across OECM. So this ranges from anything like HVAC products and services, as well as commercial air treatment, which Blade is a part of our agreements. But yeah, we work really closely with suppliers to bring that industry knowledge to our customers where it makes sense. And the sustainability and ESG factors is what we really want to focus on in the coming years. So just a very quick snapshot of who OECM is and what we do. We're a not-for-profit organization that is supporting Ontario's public sector in building efficiencies through strategic sourcing, supplier relationship management, as well as customer service. In simple terms, what we do is we run the competitive procurement so the individual organizations don't need to do that themselves. And we also manage those resulting contracts from start to end. And at the same time, throughout the contract lifecycle, we have a dedicated customer service team that is able to help customers in any way if there is any escalations or resources or any type of questions along the way. We've been established since 2006. Our focus initially started with the education sector, but we opened up our services to the broader public sector in 2009. And since then, we've been growing significantly and exponentially. We have over 1,000 customers using our agreements, and there are a lot of municipalities that are also leveraging our agreements. So really, for the folks on the line, you can really see us as sort of an ally to help you facilitate some of those conversations with procurement to really get to the resulting products and services that you need. So why did I bring up really the need of having effective conversations with procurement as a facilities person? It's because this is really what I hear from a lot of conversations we have with customers, with suppliers. Really, one of the challenges in public sector organizations we face is really is still quite a disconnect between facilities department and procurement. Facilities are really experts in running the building. They know everything from design to construction to maintenance, but procurement doesn't really have that knowledge. They're really good at securing the best deals, negotiating what's the best value based on a set of known requirements. And when things get complex, that's where procurement tends to struggle a little bit. And then, at the end of the day, there's a lot of delays, lead times, and we don't get to the end result services and products that actually help the cause or help the organization or help the building maintain in a more efficient way. So really what we've learned, and I've shared this in some of the key takeaways here, and we'll have reference to after the presentation, that projects tend to be more successful when both of these departments work hand in hand upfront. So if it's sharing some of your capital project plans early, it can give procurement teams a lot of time to plan and coordinate what are those procurement activities that need to happen. We hear that requests for proposals can even go up to a 1 full year in length in order to get from start to end. So as much time as possible at the beginning stage to help plan that activity would benefit the procurement team as well. Anytime you have some scope documents, specifications, or detailed statement of work, can also really benefit the procurement team because they can set that stage clearly to whoever the proponents are that are submitting a bid. It will also narrow down what discussion with yourself. What are those suppliers that we're looking for? What are those capabilities and requirements? And what are those goals that we're trying to achieve for your building? And lastly, a really effective way to influence some of the direction with procurement is through procurement planning stages. So procurement goes through a very rigorous process from planning to development of the RFX documents to posting it and then awarding and negotiations. At the beginning stage where they figure out how they're going to award the agreement, who they're going to send out the bid to, how should they evaluate the proposal, that can be a very key stage for facilities folks to join in on the conversation, talk about what scope exactly, how many suppliers we should award to, what should we evaluate in terms of the technical aspects, what should we evaluate as part of pricing, and sitting in the evaluation committee is also another key piece that you guys should definitely be participating in. So we're talking about procurement professionals can get creative in many ways. How is this procurement going to be different between your traditional ones and adopting of new technologies like what we have seen today? There's really many ways to implement new technologies and sustainable solutions. And there's different procurement vehicles that these professionals can sort of take. So there's more traditional requests for proposals. There are some where you seek information upfront through a request for information. There's no obligation. Sometimes it's engaging the supplier community to help with some of the design and the specifications. Some will go out for some feasibilities, tests, and pilots, which Blade also does for their case studies. Because we're in the public sector, one of the most important things that procurement teams or the government or any public sector focuses on is really the compliance to your bylaws, your procurement policies, because at the end of the day, the money that we're spending is public dollars, and we want to be wise about how we're spending it to ensure that it's open, fair, and transparent. So if you don't know where to get started, here's just a quick plug for OECM. Because we're not for profit, we're here to serve our customers. We can point you in the right direction. We have many agreements across the range of facilities. We have a lot of qualified suppliers from the design aspect to the install aspect, and everything all the suppliers have been vetted through a competitive procurement process. So you can feel comfortable that all the heavy lifting upfront that procurement tends to do has already been completed. Again, there's no obligation to commit any volume or pay any membership fees to engage with OECM. So definitely reach out to us as a resource if you are unsure what the direction is to take as a facilities person to your procurement team. So now that we have sort of the strategies and planning down, what is left to face? What are those barriers that is still lingering in the background? Well, at the end of the day, it really comes down to budget and money and cost. So there's a lot of question that comes from, hey, why change from the current state? Why change into a completely new way of doing things if the new way might potentially cost more? Well, it goes back to sustainability and organization school. If we're looking at reducing greenhouse gas emissions, there are a lot of solutions that help us get to these goals. Yes, they cost a little bit more upfront initially, but over time, you're going to get the savings back through some type of payback or energy savings. And we've seen a really great example from Noventa and Ed has described of that tangible savings. But ultimately, it really comes down to your organization's ESG strategies and how you want to make a difference in the world. Another thing to really keep in mind is there are always funding opportunities from time to time. The government has that opportunity. So if capital budget is an issue, always look for some type of funding opportunities that's available. And our supplier partners at OECM is always going to be there to help inform you and also fill out any type of application needs on your behalf to secure that funding. Another trend that we're seeing from the industry is we're starting to see supplier partners partner with financing companies or funding partners. And this will help you alleviate some of those capital budget required for the implementation or the project cost. And essentially, all the energy savings that they say they commit to as part of the project will pay back for that, we'll call it like an upfront loan, plus a little bit of interest. And then once that has been all sort of paid back, then you keep all of the energy savings for your deferred maintenance and or whatever project that you might do in the future to help alleviate that upfront cost. Because we hear from our customers a lot of the time, the barrier is we don't have the money to do a big implementation. And this could be a creative method to sort of do the project, get the savings, something great for the organization in terms of sustainability, but it's sort of amortized over a longer period of time with the proper payback through energy savings. So let's say now we're talking about project implementation now. Contracts have been awarded, we selected the suppliers for implementation. How do we keep them on their toes, make sure they don't continuously do change orders or they're not fulfilling their obligations, they're going over budget, lead times are getting out of hand? Well, it's really to make sure we have the right supplier performance and contract management in place. And here's where you really want to collaborate closely with your procurement teams or whoever is managing the contract at the end state as early as possible. Because all of these concerns, if you're looking at key performance indicators, it can be written in onto the contract before they sign it in the first place. Any type of supplier performance, obligations, or penalties. So these are some of the potential ways you can proactively track and monitor some of these potential issues before they get to the implementation stage. And obviously, there should be some type of clear mechanisms in place if you're approving changes through change orders. And the feedback that you have back to procurement is also important. So then they can make sure the contract is well under compliance and there's nothing to be worried about. At OECM, we do all the contract management milestones. So any type of supplier performance, we handle all of that from start to end. Customers that utilize our agreement come to us and escalate to us if there is a need for customer resolution. Because OECM holds the contract with the supplier, we have some degree to work with the suppliers and the customers to figure out how to resolve that issue. So the last little bit is I just want to end off with how can OECM help? Just really offering assistance and support from our organization to yours. We are a not-for-profit organization, and our whole purpose is to serve the customers that we have in Ontario and work collaboratively to make sure that both parties, suppliers, customers, and ourselves have the best outcome. So definitely feel free to reach out if you have any questions at any time. And some of the partners choose us because of several reasons, because of the trust and reputation we've built over time, the compliance aspects to some of the rules and regulations in Ontario, drive savings through a good pricing across Ontario, and we have a dedicated support team that's readily available. Before I say my final comment, I've also added at the end some agreements that we have on our marketplace that you guys can have access to. They're all hyperlinks. You can click it onto your browser once you have it. But anytime you have gaps or you see things that you want procured and it's not on the list, definitely reach out to us. We are trying to build a more fulsome decarbonization program from our list of agreements. So anytime you're doing any kind of design, build, construction, we want to be able to have an agreement in place to support any type of construction activity from start to end. So with that, I believe it's time for some questions. So I'll pass back to Kelly.
Thank you very much, everybody. Wow, I'm blown away by the information in this webinar. And I think I'm going to be reaching out to each and every individual there within this panel and asking for more information. We can populate our resources page. I forgot to introduce myself at the beginning too. I'm the MEA Climate Change Committee Chair and also a project engineer at the Region of Durham. So I'm sorry for that. And thank you very much. We're at our time. Does anybody have any questions that they wanted to post or on the Q&A for answers? I think Ed, you answered the ones that were in the chat there, the question and answer.
Yeah.
Okay, and does anybody else have any questions they want to ask for our panel? Doesn't seem to have any. That's it, I think. Okay, and you can, there's this webinar will be posted on our MEA page and the contacts will be there too. So if you have any other questions, you can always reach out to me and or I can get the contact information for you. So hopefully that ends it. And thank you very much, everybody. I can see people signing off. So thanks
Yeah.
so much. Thank you very
Great
much
job,
for
Great
the
everyone.
job, everybody. Thank you.
panel
Thank you.
members. Thanks so much.
Thanks,
Bye.
Kelly.
Bye.
Take care, everyone. Bye now.
Bye.